In today's lesson, we're going to learn to add and subtract polynomials. Our learning targets for today are to classify polynomials by degree, number of terms, and write them in standard form. We will also be adding and subtracting polynomials. Well, first, what is a monomial? A monomial is simply just a number, a variable, or a product of a number and a variable. Now, the degree of the monomial is based on the exponent. So if we take a look at a monomial, and if we just have the number 10, the degree here is 0. And here's the reason. So if I had 10 times x to the 0, well, if you remember, x to the 0 power is 1. So I'd end up with 10, leaving me with a degree of 0. Now the same thing with 3x. My exponent here is really 1. So my degree is 1. Now here's where it changes a little bit. So if you notice, we have 1/2 ab squared. While the degree is actually the sum of the exponents. And here our exponent value for a is 1. So 1 plus 2 is 3. Now for our next one, negative 1 8/10 m to the 5th power. Our variable here would be 5. Now a monomial, whole number, a number and a variable, a number with multiple variables. But you cannot have a negative variable. You cannot have a variable that is an exponent. We can't divide by a variable. And this is not a monomial. It is actually a binomial because there are 2. So we're looking just simply at 1. So monomial would just be 5 or x. So let's take a look. What is the degree of these polynomials? So I've got 2x to the 1st power, so my degree here would be 1. Now, my next one, I have 2 exponents. So I'm going to find the sum of these exponents. So 2 plus 2 is 4, giving me a degree of 4. Now, with c, I have 5x squared, y to the 1st, so that's 2 plus 1, which gives me 3. So the degree here is 3. Now, if you remember, we have our constant here, which is the same as negative 15x to the 0. So I'd have 15 times 1, which would give me negative 15. So here is the degree of this monomial. So the degree here would be 0. Try these next problems on your own. So what is a polynomial? Well, poly means many, so that's many terms. So we could have an expression with 42 terms is a polynomial. We can get a little bit more specific. Binomial, bi meaning 2, so there are 2 terms here. Trinomial, meaning that there are 3, so this is a trinomial. Now we've got a monomial, which is 1, binomial, which is 2, trinomial, which is 3. Anything else is going to be a polynomial. Now when we talk about the degree of a polynomial, we always want to write it in standard form. Now we do that by exponents. So the greatest exponent is going to come first. So this degree here is 3. That's our greatest exponent. So that means this is going to come first. Now, the leading coefficient is the number in front of that variable with the greatest degree. So when we talk about the degree of this polynomial here, it's going to be 3. The leading coefficient is going to be 2, and since there are 1, 2, 3, 4 terms, this is considered a polynomial. So let's take a look at this and rewrite it into standard form. Now, we always want to do it by decreasing exponents. So our first term here will be 9x squared. It's positive. Then minus 2x minus 8 because of the negative. So the degree of this trinomial would be 2. The leading coefficient would be 9. That is the coefficient of the variable with the highest degree. So now let's take a look at classifying a polynomial. First, let's rewrite this in standard form. So I have 7a squared plus 3. We always go by descending order. And then our degree here is 2. The leading coefficient here is 7. Now, to classify this, I have 2 terms. So this one here is a binomial. To rewrite this, 2b to the 4th minus b squared plus 6b. Remember, we always want to go in descending order of the exponents. So our degree here is 4. Our leading coefficient would be 2, and since I have 1, 2, 3 terms, this is a trinomial. Since I only have 1 term here, it's already therefore in standard form. So my degree is 5. The leading coefficient is 12, and since there's 1 term, this is a monomial. Okay. We're going to go ahead and actually skip this part here. And let's take a look at our next example. Now what we want to do is add these polynomials. I'll be honest, there's a lot of different ways to do this. So one of the ways to do this is to rewrite these in standard form, one above the other. So I have 3x squared plus 4x plus 3. One of the things I want to make sure is that all my exponents and constants are lined up. So I want to rewrite this in standard form. So I have 5x squared plus 2x plus 1. Now I can add these. 3 plus 1 is 4. 4x plus 2x is 6x. And 3x squared plus 5x squared is 8x squared. Now, the other way I can do this, and I only recommend doing this with addition. With subtraction, it gets a little bit trickier. So I can kind of combine my like terms here. So I have negative 5a squared plus 2a, which gives me negative 3a squared. A minus a gives me 0a, so I don't need to write that down. And then 2 minus 9 gives me a negative 7. One of the things I want you to be really careful about is subtracting polynomials. Remember, think about this as almost a negative 1 there. And what do we need to do? This is really important. Make sure you highlight this, circle it, whatever you need to do to remember this. We're going to distribute the negative. Okay, I'm going to get my highlighter out. This is really important because this is where I see a lot of mistakes happen when combining these like terms and adding and subtracting polynomials, is forgetting about this negative. So what I have here is 3y squared plus 8y minus 6y squared plus 4y minus 2. Now, I'm going to rewrite this one by distributing that negative. Now here, I don't have a y variable. I just have y squared. So what I'm going to do is leave a space so I can neatly line these up. Now I'm going to distribute that negative here. So I have negative 6y squared minus 4y plus 2. And now I'm adding these terms. So I have 8 plus 2 is 10. If you want to, you could always do this as a little filler to remind you that you have 0y there. So I have minus 4y. 3y squared plus negative 6y gives me negative 3y squared. My final answer, negative 3y squared minus 4y plus 10. Now, here we could do it ahead of time if we wanted to. Now remember, we're going to distribute the negative or add the opposite. So instead of subtract, I'm going to add, but I need to carry this through distributing this negative. So now I have positive 4, negative 3t, and a positive 1. So if I wanted to combine my like terms here, I can do that now. So 12t squared plus 4t squared gives me 16t squared. 5t plus a negative 3t gives me 2t. And then negative 7 plus 1 gives me a negative 6. Try these next problems on your own. Let's take a look at modeling a real-world problem. A penny is thrown straight down from a height of 200 feet. At the same time, a paintbrush is dropped from a height of 75 feet. The polynomials represent the height in feet of the objects after t seconds. Write a polynomial that represents the distance between the penny and the paintbrush after t seconds. So in order to do this, we need to subtract these two polynomials. So we have negative 16t squared minus 40t plus 200 minus negative 16t squared plus 75. Now, instead of rewriting it, if I wanted to, I can go ahead and add the opposite or distribute that negative throughout. So I'm going to add the opposite, so that makes this here a negative. So I'm going to combine my like terms. So I now have 125 minus 40t, and these cancel out. So now let's interpret the coefficients of the polynomial here. So my constant, well, that's 125. And what does that represent? This represents the distance between the penny and the paintbrush when both objects begin to fall. So the distance between here is 125 feet. Well, what does this negative 40 represent? So our leading coefficient here is negative 40, and that's going to represent the amount of feet that changes between the objects each second. All right, it is now your turn.